Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at host and iOS command. We'll be discussing IP configuration on a Windows host, on a Linux host, and on a Mac host. We'll look at the Arp command, and we'll go back and we'll talk about some of the show commands. We'll also introduce the show Cdp Neighbors command and the show IP interface brief command to verify switch interfaces. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As you're working through your daily activities, you're going to need some different tools to help you as a network administrator figure out what problems are so you can go and you can fix them. One of the tools that we look at here is on a Windows host is the Ipconfig command. One of the commands here on a Windows host that you are going to use quite a bit is the Ipconfig command. When you open up a command prompt and you type in Ipconfig, it's going to give you your layer 3 addressing information. It is going to give you your IP version 4 address, the subnet mask, the default gateway that goes along with IP version 4. You can use this for troubleshooting, verifying you have the right IP address on there, looking at making sure we have the right gateway so we can get traffic off of our network. With Ipconfig, there's also several options you can put after that. In Windows, put an option there, you put a /all. You put a / and it gives you all the options you have there. One of the most common ones is the Ipconfig /all. What this does is it gives you all layer 3 addressing, which includes IP version 4, IP version 6, and it also gives you your layer 2 addressing. It gives you all that information. You can also do some DHCP client services with that. If you put an Ipconfig /release, that releases a DHCP address. If you put a /renew at the end, that renews that lease on that IP address you got from a DHCP server. Also, there's several DNS commands you can do there. You can display your DNS, you can clear your DNS, all from the Ipconfig command. Now, I've heard people argue, well, instead of going into the command prompt and typing in Ipconfig, why can't you just use the GUI? Go in and look at the adapter settings, look at the properties, and in the graphical user interface, it'll list your IP address out there. I have seen it. I have seen it several times, maybe once or twice a year, where the graphical interface hasn't been updated with the correct IP address information. Whatever the reason is, Windows did not update that field where it pulls that information for the graphical user interface. I always go into the command prompt and I type in Ipconfig. That information pulls directly from the registry. There is no intermediary fields, or I've never seen an error with the IP address being displayed there incorrectly. And so when I pull up that IP address information, always open the command prompt, always type in Ipconfig. On Linux, we have the same command, just like Ipconfig in Windows, but in Linux, it's ifconfig. All one word, no spaces. And depending upon the distribution, it could be ifconfig, or the newer version of that is IP /A, and that'll list out your IP addresses. That'll list that out. Some distributions are trying to get away from ifconfig and go to the IP-A. You just need to know which distribution of Linux you're using. When you type in ifconfig here, it's going to list out your different interfaces. And so in this example, we have 2 different interfaces. This interface right here, ENP0S3, and then we have our LO, our loopback address here. As you can see, we list out all the information. In ifconfig, we have our hardware address. Our hardware address is the address that's burnt into the hardware on our network interface. We typically refer to this as a MAC address, but sometimes people refer to it as the hardware address because it's burnt into the hardware. Then we have our IP4 information. We have our IP address, our broadcast address. We have our subnet mask. That's all listed there. We have some IP version 6 information. We have our link local address. We have our prefix, and then it says what is the scope here. We are in link local at that point in time. We have some other informations about transmitting and receiving data, how many collisions we had, giving us all information about that. Same thing here for our other interface. It happens to be the loopback address, which a lot of times people don't use that, but sometimes on servers you do. For as many interfaces as you have in your server, in your Linux system, you're going to have listed out at this point. On a Mac OS, we have these commands also. Ifconfig is there. For those of us who know a little bit about the Mac OS, the current generation of the Mac OS, it is built on top of a Linux or Unix version. And all the commands that typically work on Linux will work in the command prompt or the console window of a Mac OS system. Ifconfig works just the same as on a Linux system. You also have a couple other stuff. We can go into a network setup command, and Apple has built this into their version of Linux. They built in this network setup command, and you can list the interfaces. You can get information based upon that. Of course, you can also use the graphical user interface of the Apple operating system itself to pull up the addressing information. Windows, Linux, and Mac, they can use the Arp command. Once again, the Arp process here is translating an IP address into the next hop for that Mac layer 2 address to start sending data across the network from network interface to network interface. You open up the command prompt window, console window in any one of these operating systems, you type in Arp, it lists out all of those connections. Arp A lists out the known IP address to Mac binding. Of course, after a certain time, those bindings are deleted from the Arp table. And to add those bindings back in, a lot of times people just use a ping command. Once you ping that, it goes through the Arp process, gets the MAC address again. You can go in there, type in Arp-A, it'll list out all the bindings again. As you're working on your network, maybe you're making some configuration changes, you're plugging in different devices to different routers, switches, and you need to clear that cache out. There's a command to do that. If you type in arp space dash question mark, it'll give you out all the commands. You can find the one to clear the cache. Word of warning though, you sometimes need administrator access to clear that cache out. In Windows, in a corporate environment, odds are your end users don't have administrator access, and so they would need to do that. But how often does an end user actually need to clean out the ARP cache? There are several iOS commands that you will use almost on a daily basis as a network administrator administering your Cisco devices. These are the show commands. They will show you information about your device. Now, some of the more common ones here is the show space running dash config. That'll show you your current configuration. That'll show you the configuration in RAM. You can go and check and see how all of your devices are set up. Show interfaces gives you the interface status and displays any error messages that those have. The show IP interface shows you the layer 3 information about an interface. You can either do show IP interface and it'll give you all the interfaces and all the IP address information associated with that, or you can specifically say what interface you want to look at. You can go show IP interface and then put G0/1 in there, and it'll give you just your gigabit 01 information. Show ARP gives you your ARP table, gives you the local known host on your Ethernet LAN. Show IP route gives you any routing information your router has, and how it gets to the destination. To show protocols, which protocols are operational. This is a big one as you're configuring new protocols on your devices. Make sure you have them set up correctly. Make sure you've turned them on. Show protocols definitely helps you. And then we have the show version. The show version gives you the memory, the interfaces, the different licenses, operating systems that your device is currently using. Show CDP Neighbors is another command that you will learn to use as a network administrator. CDP, Cisco Discovery Protocol. CDP is a protocol that Cisco devices use to communicate with other devices on the network. The option of neighbors, so show CDP neighbors, it reveals the IP addresses of neighboring devices. It reveals what devices are connected to what ports, how is everything configured. And when we look at the output of a show CDP neighbors command, one of the first things here is it gives us a device ID identifier. That's right here. And basically what that is the name of the device that is next to us. That's the name of the device that we are found through the CDP protocol. This is where having unique names on your devices help you identify how your network is configured. Then we have an address list. On this example, we don't have the addresses listed. They're typically off more to the right side, but that's the IP address on the far device. Then we have a port identifier. Here, it's listed over here on the far right side, and here it says it's a fast Ethernet 0/5. And so on the far device, we are connected into the fast Ethernet 0/5 device. Then we have the capabilities list. That field is right here. And notice we have several letters below it. We have an S and the I. If we look up here underneath the capability codes, the S says, okay, that is a switch. And then we have I. It is running IGMP protocol. So that's what our capabilities are. We then have our platform. What the platform is the model of the device on there. So the device we're connecting to is a WS, stands for workstation, C2960, and that happens to be a model number of one of their switches. We also have the local interface. What the local interface is the device, or the port on the device we are at right now. So this is R3's interface. Gig 001 on R3, that's the device we're on, is connected to device S3, that's the far device, into the port here underneath the port ID, fast Ethernet 05. And now we can kind of see how those two devices are connected. I hope you're liking this episode on host and iOS commands. If you have the time, please leave a comment and let me know what you think about some of these host and iOS commands. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. One of the other commands I've learned to love over time is the show IP interface brief command. This gives us a brief listing of our IP interfaces. Now, if you would just type in show IP interface, it gives you a detailed output of all the information associated with that interface. A lot of times it's more information than what you really need. I typically start off with a show IP interface brief command. It gives us the information we need. If I need more detailed information, that's when I do the show IP interface without the brief. Here we have an example from R1. This is a router. We do show IP interface brief here. It lists out all the ports we have. We have a couple gigabit Ethernet interfaces. It tells us what the IP addresses are. Are they okay? How did we set those addresses? We manually set them. And then what's the status and protocol? We are up and up for our gig interfaces. That means our layer 1 is correct, typically is what the status is. Protocol means we've configured our protocol, IP version 4 correctly. Everything is working on those interfaces. Once again, your goal as a network administrator to have the status and protocol be up and up if you are using those ports. We also list out the other ports that are available. We have some serial ports here. On this router, we're not using them. We don't have an address assigned to them. They are in a status of down, line protocol down. We can make the assumption that we're not using them. So if it does say down and down and you're not using them, there's nothing wrong with that. Down here we have the show IP interface for a switch. and it shows us all the interfaces. The first one it'll list here is VLAN 1 typically. It'll list out your VLANs. It'll show you, does it have an IP address or not? Did you set up your SVI, your switch virtual interface? If you did, you turned it on, you configured it correctly, you are going to have an up and up for your status and protocol for that. After your VLANs, then it's going to list out all the ports on your switch. If you have a switch that has 48 ports, it's going to list out all 48 ports. Most of the time, your ports on your switch, the physical ports, Fast Ethernet 01, 02, Gigabit 01, 02, they shouldn't have an IP address assigned to them. But if they're configured correctly, if they're configured as trunks or access ports, if you have a wire connected into that and that other end of that wire is connected into a device that has an active port on the other end, you should be able to get up and up for your device settings. And in this example, I would assume that there's nothing plugged into Fast Ethernet 01 because it says down and down, but Fast Ethernet 02 and 03, we have something plugged into it and we've got them set up, and it'll go all the way through that. And then if you have any uplink ports, those are the ports on the right side of your router. Typically, you have all fast Ethernets in the center. On the right side, maybe you have some gig ports. Those will be listed at the end, and you'll get the same information at that point about the status, about the protocol, if there's an IP address assigned to it. And once again, typically, physical ports on a switch do not get an IP address assigned to them. Let's look at the show version command. I'm going to walk you through an example here. In this example, I'm using TerraTerm as my terminal emulation program. You could just as easily use PuTTY, MOBA Xterm, or any other terminal emulation program out there. In this example, I'm going to connect into a 4321 router and look at the show version command. I'm going to press enter, and then I'm going to type in enable, and that will bring me into privilege exec mode. And then I'll use the show version command within privilege exec mode to view information about the router. At the top of the show version command, I can see the version of the Cisco iOS software that is running on this router right there, highlighted in yellow. This shows me that the router is running the universal K9 image right here. This provides all of the basic Cisco iOS features, including support for strong cryptography. This is the extended maintenance package that is signified by the M right here at the end. Next, we can tell that this is major release 16, minor release 6, and build number 4. And that was major release 16, minor release 6, and build number 4. Also on this screen, I can see that the router has been up for 4 minutes. I'll press the space bar to display more output. This tells me the name of the iOS image file, and that it is located in boot flash memory. ISR 4300 refers to the hardware platform that this was built for. And you'll recall that I'm using a 4321 router in this example. And again, here is the version for the iOS image file. SPA means that the image file has been digitally signed. And the bin at the end of the file name refers to the file format that this file is in. And in this case, it's in a binary format. The next line down here, we see the reason for the last reload. And it was because I issued the reload command. This information can be helpful, especially if you have a router that keeps crashing. Below here is information about the cryptographic features of this router. I'll press the spacebar twice to display the rest of the output. Next, we have information on licensing. It is broken up into two categories: suite licensing and technology package licensing. First, let's look at technology package licensing. This indicates we have a permanent license for the IP-based K9 package, which is the default image set and the package and feature set that was specified when the router was ordered. And it shows that it will be available on the next reboot. We currently do not have any other permanent or evaluation licenses installed. If we wanted to upgrade our iOS or install new features, it is a 3-step process. First, purchase the software, package, or feature, and obtain a product activation key, or known as a PAC in the Cisco world. Second, obtain a license using your PAC and the UDI of your device, which is the unique device identifier. And lastly, install the license. We could purchase a suite license that includes multiple features. If we did, that information would appear in this information here at the top of the screen. Next, we see that roughly 2 gigabytes of DRAM have been partitioned into main memory and shared memory. Main memory is reserved for the CPU to execute commands and also holds the running configuration and routing table, among other things. Shared memory is used to buffer data as it's transmitted or received on the interfaces. The contents of DRAM will be lost when the router is powered down. Next, we see the number and type of physical interfaces. Here we have 2 gigabit Ethernet interfaces, and we also have 2 serial interfaces. The line below the interfaces shows us we have 32 megabytes of NVRAM, or non-volatile RAM, which is electronically erasable and reprogrammable. This is used to store the startup configuration file or saved configuration, and the configuration registry setting as shown down below. But we'll get to that in a second. The content of NVRAM is retained when the device is powered down. Next, we see that the router has 4 gigabytes of physical memory. This is the total amount of DRAM, which includes the main and shared memory as we discussed above. Again, all contents of the physical memory is lost when the device is powered down. Next, we have approximately 3 gigabytes of flash memory used to store the Cisco software image and other system files. Lastly, we can see the configuration registry setting written in hexadecimal. This is the factory default setting, which instructs the router to load the iOS image from flash and then load the configuration file stored in NVRAM. But what if you cannot remember your password and access your router? You can change the default boot process by altering the configuration register setting so that the configuration file won't load from NVRAM on boot up, allowing you to access privilege exec mode without a password. You can see that the show version command gives us basic information about the router, including the iOS version, how long the router's been up, and how much memory and storage the router has. This information can be helpful during troubleshooting or when upgrading your iOS. It was my pleasure to provide you with this wonderful episode on host and iOS commands. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.